Welcome to notes 6.1 to 3. We are going to be talking about ratios, proportions, and similarity. And the reason why we're talking about ratios and proportions is because of similarity. And you will see when we get to that, when we start talking about similar polygons and similar triangles. All right, so you've been dealing with ratios and proportions for quite a while now. And that means that you are aware that the ratio of A to B is A over B when B does not equal 0. Obviously, we can't divide by 0, so the denominator of my fraction cannot be 0. All right, so we can write a ratio as a fraction. A proportion is when we put two ratios together. So it's an equation that states that two ratios are equal to each other. All right, and then in a proportion, the different parts of the proportion have different names. So if I have a proportion that states that A over X equals X over B, X is known as the means, and A and B are going to be called the extremes. So students tend to forget this. I'm not totally sure why. Again, means are the ones I like to think of as kind of the middle ones, and then the extremes are the ones on the two end. So when I use these terms, you'll know what I'm talking about. Okay, and then you guys are familiar with the mean, meaning the average of two numbers. Well, that mean is actually an arithmetic mean. There's also a geometric mean, and in a geometric mean, if we take the geometric mean of two positive numbers, A and B, it's the number x that satisfies the equation A over x equals X over B. So essentially, x is the geometric mean. This is an equation that you need to memorize. We are going to ask you about the geometric mean, and it's so very easy, and yet students totally forget it. So be sure you commit that one to memory. Okay, and then a scale drawing is a drawing that is the same shape proportionally as the object it represents. A scale drawing is the reason why blueprints aren't the same size as the house, right? It's why we can draw things on paper to represent much larger things. Those are known as scale drawings. Okay, and then we have similar polygons. Similar polygons are polygons in which the angles are congruent and the sides are proportional. Again, angles are congruent, sides are proportional. Okay, and then if there are similar polygons, then they must have a scale factor, and the scale factor is nothing more than the ratio of the lengths of two corresponding sides. That will give me my scale factor, and we're going to do that a bunch. Okay, so you should be familiar with proportions, and you may or may not know that there are some properties that apply to them. And the first one is the cross products property, and it simply states that if I have a proportion, then I can cross multiply to solve the proportion. So AD will equal BC. Okay, and you can prove it with this one. I don't quite know why they've written all this, but I could say that 2 times 6 equals 3 times 4, and sure enough, I get 12 equals 12. Right. Then there's also a reciprocal property, which states if two ratios are equal, then their reciprocals are also equal. So if A over B equals C over D, then B over A equals D over C. I can flip them both, and they will still be equal. There will still be a true proportion. Okay, these next two properties you may be less familiar with, and this one says if you interchange the means, remember the means are the middle two parts of my proportion, then you form another true proportion. So if I begin with A over B equals C over D, and I exchange C and B, then I wind up with A over C equals B over D. I've simply exchanged the inner part of my proportion, and I still wind up with a true proportion. And then finally, in a proportion, if I add the value of each ratio's denominator to its numerator, then I form another true proportion. So if I have A over B equals C over D, and I add B to A, and I add D to C, and put it over D, then that is also a true proportion. Okay, this one is the one that most often gets students. This is the one they most often forget. So please go ahead and right now commit this one to memory. Okay, so here's some examples. We like to simplify our ratios. So if I have 76 centimeters to 8 centimeters, I can also write that as a fraction, 76 over 8. And then obviously I would want to reduce that fraction, and it reduces to 19 over 2. Now, this one, I can reduce this and keep it in this proportion. Okay, so this would be 1 foot to 6 inches, or I could convert these, right? So I can convert the inches to feet. So I would have 4 feet to 2 feet, which means I would actually have a 2-to-1 ratio, which is really what this is saying if you think about it. There are 2 of these in 1 of these, but that's just a concept that you can either convert the units or you can keep the units the same. And in this one, I don't have to express the units because they are the same, but in this one, I must keep the units because they're different. Okay, and then we have these things called extended ratios, which are kind of cool. And it's a ratio of more than 2 numbers, 2 values. And for example, if I have a triangle and I know that the measure or its angles are in an extended ratio of 1 to 4 to 5. So I've got this triangle, and essentially, let me move my triangle. The ratio is 1 to 4 to 5. What I'm really saying is that if this one is 1x, then this one would be 4x, and this one would be 5x. And I can find the measures then because I know that the sum of all of those must equal 180. So I would take x plus 4x plus 5x, and I would set it equal to 180. And these guys all add up to 10x equals 180, which means that x equals 18. And then the measure of the angles are, one of them is going to be 18 degrees. The next one's going to be 72 degrees. And then my final one would wind up being 90 degrees. I would like you to please find me the geometric mean of 4 and 9. And if you need to go back and refer to your notes for how to do that, please do so. Remember, if we were to do the arithmetic mean, we would just take 4 plus 9, and then we would divide that by 2, and we would wind up with 13 over 2. Okay, but that's not what I'm talking about here with the geometric mean. So please go ahead and solve this, and then come back when you have your answer. Hit pause now. Okay, so I would have done 4 over x equals x over 9, and that means, oops, didn't mean to put an equal sign there, that when I cross multiply to solve, to use my cross products property, I get x squared equals 36, and that means that x equals 6. And we're only going to consider the positive value, geometric mean. We always use positive numbers, so we're going to talk about the positive root. Okay, in this diagram right here, I'm told that some of these side lengths are proportional, so all I really need to do is fill in the sides with the values that I'm given, and then I can find what I am missing. So let me see, JL is going to be this piece right here. I don't actually know a value for it, but I know this whole side is x, and this part's 2, so JL must be x minus 2. And then LH is 2. And JK is 15, and KG is 5. Please solve for x. I'll wait. All right, you should have gotten x equals 8, which means that when I find the things I want to find, which is JH, so if x is 8, then JH is 8. And then JL is going to be 8 minus 2, which is 6. Okay, I talked earlier about how the reason why we were learning about perimeters and ratios yet again was because we were going to be talking about similar polygons. And remember, the thing that makes polygons similar are that the angles are congruent and the sides are proportional. Well, what we find out is that if the sides are proportional, then when I add up all the sides, what I get is still proportional. And when I add up all the sides of a figure, that is also known as a perimeter. So my theorem states that if 2 polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So this is the ratio of their perimeters, and that's going to be equal to the ratio of KL to PQ, and the ratio of LM to QR, and the ratio of MN to RS, and the ratio of NK to SP. All of these ratios are going to be exactly the same. So ratio of the side length is equal to the ratio of the perimeters. Very important concept. Okay, and then let's talk a little bit about corresponding lengths in similar polygons. If I have two polygons that are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. And we dealt a little bit with this when we were talking about congruency. We talked about corresponding parts. Okay, similarity works exactly the same way. This little symbol right here states that they are similar instead of congruent. And what that tells me is, because I know my similar figures, my angles are congruent, then I know that angle P is going to be congruent to angle X, and angle Q is going to be congruent to angle Y, and angle R is going to be congruent to angle Z, right? Just like it was in congruency. But then I know my side lengths are going to be proportional, which means that PQ is going to be the ratio of PQ to XY is going to be equal to the ratio of QR to YZ, and also the ratio of PR to XZ. Okay, angles are congruent, sides are proportional, and this ratio is going to give me the scale factor of my polygons. So if I ask for, or if I'm trying to find the scale factor of LMNP to FGHJ, I just have to find a pair of corresponding sides. So let's see, GF is going to correspond to ML, which means that I've got 15 over 12, and then when we reduce that, we wind up with 5/4, and that's going to be my scale factor. You could also say 4/5. Right, 4/5 would be okay. And actually, in this case, since I'm going from the larger to the smaller, I would probably go with this as my scale factor because it shows how I reduce. Oh, I take that back. I'm going from the smaller to the larger. Man, I'm having issues today. So then exactly the opposite of what I just stated. Since I'm going from the smaller to the bigger, I want to use the scale factor that's going to make my value get bigger, which would be this one. Okay. But again, if I don't specify, I'm fine with either one of these. They will give me the scale factor. Okay, and then if I'm going to find the value of X, I need to set up a proportion. So my proportion would be 5/4 is going to be equal to, and then I need to do my corresponding sides. Well, 40 is on the bigger figure, so it goes with the 5, and X is on the smaller, so it goes with the 4. All right, I need you to find me X, please. I'll wait. Okay, and so we find out that X equals 32. Okay, so I would like you to answer 4 and 5 for me in the notes chat, keeping in mind that the ratio of the perimeters is going to be equal to the ratio of the sides. So there are two ways to do this. Either you find the two missing sides and add them all together, or you find out what the ratio is and the perimeter of this one and use that in your proportion. And we can talk about this tomorrow if you're confused by anything I just said. Also, I want you to find the length of the median in this one. And just like all my sides are proportional, if my triangles are similar, the parts of my triangle, so the segments, will also be proportional. All right, this concludes today's notes. Please go on and do the notes check. Thanks.